Alright, and we are live. Hello everyone, how's it going? And welcome to today's little live stream. Today's going to be a little bit different than the other days, where in the previous days I would show you how I made this specific effect. Today is going to be a speed run, where I try to make this kind of stepping effect, not with all the polish and such, but just getting the basics of the effect down in the quickest way possible. It'll be my first time trying to do this, so it'll be quite interesting. So, and I'll just showcase what I have right here. So I have the little walking animation. You probably saw this on my YouTube channel today. And instead of having the robotic legs, I just swapped them out with a stick, which I found on Sketchfab. It's a very nice stick. But yeah, I just did that, and turns out it looks very, very good, which I'm very happy about. So, in about 30 more seconds, I will start the speedrun, trying to recreate this effect. Again, it won't be nearly as good as this one, because I spent a couple days working on this, iterating. But now that I know the final result, maybe I can make it better. So I'll just wait a little while longer, so that more people can join the stream. But once they do, I will begin on a fresh new scene, which I think this will work quite well. So my favorite one is the one with the most amount of legs, because it's just, oh, a ton of sticks just walking by. Very cool. Yep, so it's very nice. Okay, so yeah, I'll wait just 10 more seconds until we hit the 2-minute mark, and then I will begin the speed run of making a similar effect to this, but not the same, because it'll be extremely, extremely fast. Okay, so let's start a new file and recreate this from scratch. New general, I keep forgetting I have to do that. Okay, so first of all, I'm just going to start out with the points, the leg points, and let's start out with 10 points. There we go. I'm going to delete the edges and vertices so that we're just left with these guys right here. So let's get started on making this be able to move. So there we go. So first thing I'm going to do is set up a target for this to go to. So I'm going to move this empty over to here and make it so that the target geometry is over where this is. That's pretty simple. I can use a transform geometry node right here, set it to relative, and plug all of those into there. So now we should see it transports over to here. So now these vertices have a location at this empty that they will try to go towards. So let me move this back, turn on grid snapping. So now it is time to add in the simulation node. So let's do, simulation output, simulation input. Let's put it right here. So we just want the default geometry to be put into the simulation, and then that to be like that. There we go. So now that we have that set up, now let's just set up a version of this just to show that it's working. So the simplest way to do that is to use a set position node, and then use a sample index to transfer the position. Since the geometry is the same, I can transfer a attribute, in this case the current position, to the new place. Whoops, sorry about that. Position, and then let's do index, so that since the indices are the same with the default position geometry and then the move geometry, I can transfer that easily. And I'll just mix between that new position and the current one. In this case, it'll be mostly biased towards its own position, which means it'll be quite delayed. But now we should see, boom, it moves, which is very good. But now I need to make it so that it's stepped, which won't be too difficult. So what I'm going to do is, let's get the offset from the target position to the current one. So I use a subtract node just to get the offset. So if I were to just plug this into the offset right there, we would see that it would teleport over there and constantly be there if I were to move it around, because it's just the offset. But what if I want to make it a little more, not instant, but custom? So for that, I'll use a normalized node to make sure that it's just the direction with a power, in quotes, of 1. Then if I scale this by like, let's do 0.05, we'll see that this will move that amount over time to get to the target locations. One little issue is that it will freak out once it gets to there, but there's a way to prevent that from happening, which I may show later. So let me put this into a frame just to keep that going well and move it over. So this is our little offset node and then the normalize and all of that. Let me implement the stopper thing. So let me set this to 0.1 so that we can see the results faster. So instead of it freaking out, I will use a length node, just like this. And then if I use a maximum node, I believe it's a maximum, and set it to 0.1, this will make it so that, no, this needs to be a minimum. There we go. So that makes it so that it'll move, but if the length is shorter than this, it'll just stop. It'll just do what it's supposed to do. So now that we have this, it's fully working, just moving the particles over to where they're supposed to go by a set value. There we go. So let me label this. This will be, let's see, get target position. This will be target offset, and this will be limiter. There we go. So that's that, which is very simple. But you may be wondering, well, how do we make it kind of step over time? Well, this is the easy part. So let's get the scene time node. And now, if we say, let's divide the scene time by, say, 20 frames. So there will be 20 frames in between each cycle. So let's use a fraction node after that so that it loops. And now, if I use a greater than off of that, let's say greater than 0.5, if we scale the offset by our greater than, then we should see, there we go, it's now stepped, which is exactly what we want. We just want it to do that over time. So every 10 frames, because the greater than is at 0.5, it'll move, and then another 10 frames, it will be completely stopped, which is very good. So let me do that. But now we want this to be randomly offset for each vertice. Again, that's easy to do. We just use, oh wait, I need to use an add node before the fraction. I almost did it after, before there, and we just add in a random value node. And since it's between 0 and 1, it'll affect it correctly. So let me just put that in there and randomize the seed. So now we can see that the stepping is working, and working very well. So yeah. So with that, that is good. Oh wait, I forgot. So the way that I had this set up in the other file was that I made a map range gradient that would affect what time, basically what the greater than's doing here, but with more customization, so that I could then do the leg or the foot hopping thing later. So let's do that. So instead of that, I'm going to bring this up to here, and I'm going to store this as a named attribute, and I'll label it time gradient. There we go, I spelled that correctly. Yep, that seems to be. Then I'm going to use a map range to do the 0.5 offset. So that 0.5 to 0, it'll scale from 0 to 1, pretty good. So if I plug that into there, and then plug in the time gradient into here, something will be a little bit amiss. It starts off slow, then it speeds up, then it stops, and so on. So one thing I could do is just use a equal to node, which is like the greater than node. But I'll just set it to be 0.5 and 0.499, which means that basically when it's inside the time gradient, it'll do the same thing. But now that we have that gradient happening, I could say that once you're doing the time gradient, you make it hop over that. And that will be a post effect. So let me show you what I mean by that. There we go. This is time gradient. There we go. So in post, after the simulation node, we can affect the position without it messing up the movement. So let me do that. Let's use a set position node. And with this one, I'm going to use the time gradient. Whoops, let me copy over this to affect the z offset. So let me use a multiply node, a vector math multiply, and set this to 1, just so that we can see what's happening. So here we can see, since the time gradient is offset, whenever it moves it up. but I don't want it to move up like that. So let's use a float curve to make it, you know, hop. And we can customize the shape using this. So here we can see it's hopping perfectly. A little bit too tall, so let me limit that by a bit. So there's just one more thing that kind of has to be done for it to work well. As we can see, it hops even when it's still, which we don't exactly want, but there's an easy fix for that. We just need to store another named attribute. So let me go and label this, let's see, pick vert up. Pick vert up. That seems to be all right. So how do we make it so that it doesn't hop when it's not moving? Well, that can be pretty easily done. We just store the offset and then reference that later. So I'm going to store another named attribute. This will be a vector, and this will just be offset. So I'm going to store that into here, and then I will reference that attribute and put it into the offset here so that we don't have to calculate it twice. There we go. Let me put this right over to here. Let's put that in a frame. That seems pretty good to me. And now we could reference this offset, not the time gradient, the offset. There we go. Basically get the length and say, and we can scale the hop based on how fast it's going. And we could put like a greater than at the end here to say, hey, if the velocity is greater than like 0.01, then move just fine, which I could do, and let me play that. But if you take into account, yeah, there we go, that happens. But if we just plug in the length into there, that means if it hops just a little bit, then it'll just do a little hop, not a huge hop. So we can see that. So with that, I need to bump up the default height by a little bit, but we can see that's working just fine. And let me move this around. As we can see, it's working, and working very, very well. So that's that. So that's the foot placement thing, fully working. And the node setup isn't that bad. I set that up in 10 minutes on the dot. But there's just one more thing we need to do, and I'm going to set up a new geometry node after this, just so that we can keep it nice and organized, which is how do we connect all the points on here? Well, the way to do that is we're going to extrude the mesh, but we'll set this to vertices, which these are set to be in a weird place, but that doesn't really matter. And then we're going to use a set position node, set it to only at the top, and then we're going to reference the average of all the vertices right here. So the way to do that is to use an attribute statistic, and we'll set this to vector, so we'll reference the position. And then if we get the mean, this is basically the average, and hook that up into there, we can see, boom, it's just connected all of those, which is very, very good, very nice. Then we can offset the middle like that. Let me hide the unused sockets. So right there, we can see that we have the center doing its job, which is very nice. It's not delayed. I could use simulation nodes to delay it like I did in the official version, but this is the fast version. So yes, let me do that. And let me also turn on the floor axes just so that we can see it a bit better. So let me set up another little animation for the sky. Let me keyframe this here. And then let's do another keyframe over there. Let's set the interpolation to constant. So let's let that play. So now what if we want to customize like the arc of those curves? Well, that's pretty simple. Or these are meshes, not curves, but we are going to transform those to curves. So mesh to curve. Let's do that. Let's resample the curve so that there are 10 points along here. Let me just use a curve 2 points node to demonstrate that. Set this to evaluated. So instead of just 2 points like it is originally, I'm going to set it to 10 or maybe 20. It doesn't really matter too much, it just makes it look better in the end. So there's that, and I should label this as start to average position. There we go. So that's the curve, and now I'm going to use another set position to offset the middles of these. So if we get the spline parameter, we can get the gradient from the center to the outward part. And then using a float curve again, we can set a custom kind of shape for it. And then I'll use a vector math multiply again and plug that into the offset, and we should see when I do this, it works, but it needs some customization, so let me do that. Yeah, right about there. That seems pretty good. And now we have a walking creature. Now, it would help if I delayed the centerpiece by a little bit, but you know what? For this little test, for this speed run, it worked pretty alright. In 15 minutes, I was able to set this up, which you could say is good enough for a regular tutorial. Maybe I'll condense the live stream into that. But yes, that is the effect. That's the basics of how I made it, and it turned out pretty good. Let me just do that. And then we can, you know, mesh the curve and all that, which, yeah, let's just do that just for thoroughness. So curve, operations, curve to mesh, and then let's make the profile curve a circle, curve circle. Let's severely reduce the radius, just like that. Fill the caps. We could set the profile to be custom, but in this case I don't think it's all too needed, just because I want them to kind of be sticks. Actually, no, let's do that as well. Do all of the things. So let's use a set radius node, set curve radius just like this. Now I'm going to copy the spline parameter over and hook that up into there. So now we can see that now we have a custom radius for this. I could make whatever I want, which is quite nice, if I do say so myself. So there you go, you got your weird looking alien creature meshed, and then we can set the material right after that. So let's set the material. Let's make this just the default one. Let's put that into a frame just to keep it nice and organized. And actually, let's put this one in the frame as well, just because not too much is happening over there. I'll keep that one outside of it. Let me label these. So this will just be mesh to curve, sorry. And then this one is middle height. Yeah, let's do that. Middle height. There we go. Whoops. Then this one is radius. And then this is mesh curve. There we go. So now we can color this however we want, and it'll do its job. Very nice. So a nice green alien sludge monster. Here, let me... Yeah, there we go. Very nice. One thing is that the hopping is happening a little bit too abruptly, so let me go and ease that by a bit. There we go. So that is a little bit better. It eases and it makes the centerpiece a bit better. So there you have it. That is the effect, and it works well. Another thing is that you can just keep adding points. This will look very weird, but hey, experimentations. So now you have a giant thing doing that as well. So let me go and undo that, just because it's, you know, just a little bit odd. And what other colors? Maybe, yeah, kind of a red color. Let me turn off viewport. Oh, nope, that's already off. But yeah, that is the effect. Yep. So if you guys have any questions, please let me know. Or else I will... I don't know, what should I do next with this? It seems pretty straightforward for the time being, and if you want to do a deep dive into the effect, well, I did. Back in the previous live streams. So take a look at that. Let's see. I wonder what it would look like if you changed the seed on the circle random points node every walk cycle. It would be jittery, because if I were to do that, then it messes up the time for them. All of them are programmed, or quote-unquote programmed, to be in a cycle. So if you reset the cycle in the middle of it, and you can't really... Can you do that? Here, let me see. Let's use a snap node to see if I can change the seed. That may be possible. Yeah, no, it doesn't seem to be working all too well. I think that's also because of the fraction node. Wait, this will be yeah, it's a circular dependency. So unfortunately, no. If I had like a simulation node, that's a possibility, but I would not recommend it. Oh, and another thing that you could do instead of having a random value be the determiner for that. One thing that I did in the previous version. Let me store the default position. So before any offsets happen, let's just make this old position. You can make it look a bit like a centipede. So if I just take the, whoops, let's do that. Old position, use a separate x, y, z, then a multiply. I can make it so that it's location by the origin, or the distance to the origin will determine how that looks like. So now we should be able to see if what if I lower that by a bit? There we go. We can make it do a wave, which maybe you want, maybe you don't, but looks kind of cool. Okay, let me turn back on the random value and chop this out again. So yes, in under 20 minutes, we got a working effect, which is very nice. And also, because we can, let me showcase this. Yeah, you can rotate this. Okay, let's speed this guy up by a little bit. There you go. So it walks there. Oh, that's a weird thing when it goes and then it just stops. There is... Okay, so another way we can use with the time gradient is using a ping pong node and then a multiply by 2 node because the ping pong kind of halves the value. And this will make the speed ease so that won't happen, that little snappy part. Yeah, there you go. Oh, that's a hyperbolic tangent. No, I want a ping pong node. There we go. Yeah. It makes the easing just a little bit smoother, and since the speed is doubled, let me reduce the height. There you go. So now it's not doing that super fast thingy. It's more slowed down, a little more mellow. So this will be, is allowed to move, kind of. Move amount. Move, yeah, let's make this move time / amount. There we go. In the future, it might be interesting to use this geometry node animation technique to animate bird / dragon wings. That's, like, for procedural birds, like, it would have to be very different from this one because that's a whole nother ball game. A whole nother ball game. Quite difficult. Oh yes, I can scale the points down, so let me show that off, so that they choose to go in a smaller space, or I can rotate it and such and it'll work as well, so let me do that. You can see it kind of rotates, but with the interpolation being off, it's kind of, you know, not quite as good. So let me wait for that to happen, and then we can see, yep, it does a little rotate, then it moves over. Some clipping will happen, which I cannot avoid in this current version of Blender, but in a future version, there's the index of nearest node, which means I can see where the closest point to the vertices are, so if they get too close, maybe I can make it so that they move over a little bit. But for now, this is the best that we have, and it works quite well. Another thing that I could do, but would make this a lot more complicated, is to use the weighted average mode that I had before, to make it so that the middle kind of moves over time, but that only works when you have a simulation to simulate where the middle should be as well. You know, to add a little bit of delay, a little bit of physics and such, outside of the scope of this speedrun. So yeah, and that's the effect. It works quite well and does everything, pretty much everything I want it to do. Okay, so let's change the stepping time. So now we just sped it up by a ton. You know, not quite what I want. In this case, I slowed it down, which makes it a lot more creepy and sneaky. Let's see. Yeah. For the bird animation thing, that unfortunately geometry nodes cannot interact with rigs or bones, unfortunately. And for the time being, you know, we're not going to get that for like probably over a year. But for like procedural little birds, like if you have a flock of pigeons here, like just having instanced wings on the two sides of them, then making those flap while they fly around, that's very doable. I do foresee being able to do that in the future, but again, I'm kind of waiting on the index of nearest node so that the birds can see where their neighbors are and follow the path like real birds would. But I think where I would have like a set of points like these, and then I make the points fly up and then land on a certain mesh, that's going to be possible very, very soon with the, you know, self-avoidance things, because this is deterministic. Because this is literally, referencing where these are and then going there. And unfortunately, they don't know where their neighbors are, so they just clip. As we can see, well, they're very thin, so they don't clip all too often, but it does happen. So yes, if there's anything else you guys want explained, I will do that. If not, then I think at the 30-minute mark, I will end the stream, because it's past 10 o'clock where I am currently. Also, I still haven't found a good ragdoll simulation with physics yet. Yes, that is far into the future. Once we get loop nodes, it might be possible. Again, not with rigs at all. Yeah. It won't be possible with rigs, but there's a possibility that maybe if I get a mesh, I may be able to like make a pseudo rig using vertices and then make it do whatever I want. Let me set up another animation instead of replaying this one again and again. Let's make it go over to here, and then over to here, and then over to there, and then let's reset it. There we go. And I could speed it up, but I don't think that's entirely necessary. Let's see. And let's also put in a ground plane just so that we can see what it looks like. There we go. And let's change this to a darker color. Maybe a bit more reflective. No, that's fine. But yes, that is the effect. So any last questions, I'll take them. But then we'll be ending in 3 minutes. Actually, maybe a little bit less. By the way, there's newer experimental 6.0 sim node builds, by the way. I don't see much difference except the way it loads the sim node. Ah, that is, yep, that's most likely, yeah. I am waiting for it to be merged into the main branch to like really start doing stuff and putting out products up on Gumroad, which I have quite a few products up on Gumroad, shameless plug. But all the simulation node stuff I cannot put up on Gumroad until it gets merged into the alpha build, which I think we're probably over a month away from that happening. Because currently, in what I've seen in the dev talks, the simulation build node might have some caching now, but there's a lot of features missing. It's very similar to what we currently have, and this build is probably over a month old at this point. So I'm currently just doing what I can with what I have until it gets, you know, we get support for the other stuff. Let me add in some random points just to start off. So yeah, now you could even do that in geometry nodes. So let me do that. So let's have some points. Oh, points, just points, not mesh to points. Let's add in a random value node. Pretty standard, just that and that. So let's take a look at the output there. So let's just add in, yeah, 20 seems good. And let's change these points to vertices because otherwise the extrude will not work. Points to vertices, there we go. So now we have randomized points, which means that we can, you know, make it look a little less regular. And add in a ton more if we so desire. So you could have a walking carpet, I guess? But yes, it is interesting seeing it work with so many vertices and stuff. So yeah, if I wanted to make this a lot more complicated, it could be interesting, but we'll see. Oh, just a few legs actually looks kind of adorable. Air simulations, that I have tried that before, and it's a big pain to do until we get loops, so it will be a while. Or when I figure out how to use the curve indices right. And also the index of nearest so that the hair can have collisions with their neighbors. But yes, it'll be a while. Lots of features are missing to make simulation nodes fully good, but in this case it's enough for a nice little blob. Our nice neighborhood blob. So yes, one more thing that I could try is let's give it more time to walk and less time staying still. So that makes it feel a little bit more floaty, which isn't exactly too good. Let me actually chop these out and see how that makes it feel. Yeah, it feels extremely floaty. But if I were to reduce the time, the looped time, it actually makes it feel not bad. Gets kind of the prancing feeling. Let me set this to 0.8 and then change the time up a lot more. So here we can make it have almost a stalking pattern. Just like, oh, I'm just sneaking up. I'm not going to kill you, totally. But yeah. And then I can turn up the speed again. So that happens, but I think maybe 0.7 would be better. Let's tone down the time. Yeah, not too bad. Not too bad, I would say. Alright, everyone. I think I will call it for the stream now. We're at 32 minutes. But hopefully you all enjoyed. You know, this effect, it's not that complicated once I figured out the best way to do the math. And yeah, let me set the parameters to be correct. And make that 25 again. I just joined. Well, this is a shorter stream. I would recommend re-watching it from the beginning because I make this little effect from scratch. It was a speed run, so it was going to be very fast, and yes. So, yeah, thank you all for watching, and I will see you next time.